cloud chamber, also known as a Wilson chamber, is a particle detector used for visualizing the passage of ionizing radiation. Isopropanol vapor saturates the chamber. The alcohol falls as it cools down, and the cold condenser provides a steep temperature gradient. The result is a supersaturated environment. As energetic charged particles from background radiation pass through the gas, they leave ionization trails. An alpha particle track is thick and in most cases straight, while a beta particle track is wispy and shows more evidence of deflections by collisions. Now a small amount of radon is injected into the chamber. This chemical element is a radioactive, colorless, odorless, and tasteless noble gas. The Radon-220 is a natural decay product of the most stable thorium isotope and is commonly referred to as thoron. It has a half-life of 55.6 seconds and, as we can see, emits alpha radiation. This view is truly mesmerizing, especially when we realize that each of the tracks we observe is caused by a single alpha particle, a helium-4 nucleus consisting of only 2 protons and 2 neutrons.